Hello, I'm Hotta. I'm the Secretary General. I'm going to be leading the closing remarks of this session. So today we're talking about Japan-Germany collaborative efforts. Back in 2016, we had a joint statement with regard to digital efforts, and we've been working bilaterally on that. And today we're reporting on the progress that we're making. Ahead of all the presentations that we had, we're going to have a few opening remarks from representatives of both the Japanese and German governments, beginning with Ms. Miho Kawamura, the Director, Manufacturing Industry Strategies Office of the Bureau of Manufacturing Industries of METI. Hello, everyone. Thank you for that introduction. I'm from METI. My name is Kawamura. So ahead of my opening remarks, I would like to, first of all, express my thanks to Mr. Hess, Deputy Director General of the German government, as well as RRI and those associated here in this forum. And also, I would like to say thank you for all of the efforts to all other personnel involved in putting this symposium together. I would like to express also my gratitude for everybody who has attended and shown interest in this event. From this morning, there's been some very interesting sessions I personally, from METI, have been watching. So talking about the manufacturing industry and the importance and criticality of data linkage and how to deal with that, I think there's been a lot of really imaginative discussion and ideas which have been described today. So, for example, having more robust supply chain, looking at environment, looking at human rights and due diligence. So talking about risks and also supporting legal and regulatory aspects, not just that, but also leveraging data to be able to generate new business models so that you can add that as additional value to your own company so that that becomes sustainable competitiveness. Those opportunities and potential is something I think many of you will have held having heard the presentations. At METI, once per year, we produce a white paper for the manufacturing industry. This fiscal year, 2023, inside that white paper, we talked about the external environment that's significantly changed for the manufacturing industry. And also, in order to respond to those changes, you have to get beyond the boundaries of a single company. You have to look at the industry as a whole. You also have to go beyond national boundaries to be able to collaborate internationally. And also, the key is digital linkage and digital collaboration. That's the message that we contained in our white paper. Now, in terms of actually putting that into practice, data collaboration needs to be successfully leveraged to be able to produce new models, and many businesses are being able to do that now. That is something that is becoming a key for future growth. That's something that we've covered in the white paper for this year. So based upon that, at METI, we've been talking about putting in place the right environment for business. So across academia, industry, and politics, we've been looking at initiatives for leveraging data. So we started coming up with an ecosystem. We're trying to find ways to do data collaboration. So in terms of Japan-German collaboration, 2016 March, that's when with Germany, the German government and METI, we produced a joint statement. And as the department that is in charge of implementing this, RRI has been performing a really big role in those intervening years. At this session now, we've had more than 130 meetings of experts talking about standardization, industrial security, as well as, of course, today's main theme, which is data collaboration. So we're going to have presented to us the outcome of all of that effort and discussion. And at the very end of the session, we're looking at going beyond just Japan and Germany and looking at some of the global moves, the International Manufacturing X Council. We're going to be talking about that. I hear that there's going to be a presentation on that. So this is going to be a first presentation before it goes out into the world. I'm very, very happy to hear that it's being presented here at this symposium. First, it really reassures me about the strength of the relationship between Japan and Germany. I hope that this is an opportunity for further international collaboration going forward. Through this symposium today, for all the stakeholders involved, the importance and possibility of data collaboration is something that I hope you recognize and that you take that away into your own areas of expertise and specialism. And if you are in business, that you then embed that into your own company so that you find concrete ways to move forward. I hope this is a trigger for you to do that. I hope that this continued symposium effort will be great in terms of outcomes. Those were brief, but those are my remarks. Thank you.
Thank you very much, Ms. Kawamura. Next, please switch the slide to welcome Mr. Hess of BMWK.
Dear Kawamura-san, dear Hotta-san, ladies and gentlemen, thank you very much for the invitation to the afternoon session for the Industrial IoT International Symposium. I'm very grateful to be here. It's a pleasure as always, and it's as fruitful as the predecessors of this symposium. In the German-Japanese relationship, there has been a lot of proof that we can trust each other, that we can build upon each other's experience, that we can work jointly to find solutions, and that there is a long-standing and trustful economic tie web, so to speak. We are proud that we can look back at a long-standing and fruitful cooperation, also between the Plattform, Industrie 4.0 and RRI. On today, we've seen once again, we're all committed to drive the digital transformation of our societies and industries. So, in short, the fourth industrial revolution is in full swing. Looking at industry and the challenges ahead, again, this symposium underlines the future of industry will be data-driven, no doubt about that. It is about enabling data-based innovation, applications, and business models. The change that is necessary is cross-sectorial borders, leaving silos across countries, in the end across the globe. That is a consequence of a globally intertwined, interlinked industry of today. The focus in this respect is therefore shifting to cross-company collaboration, covering the whole value networks. It is a real challenge, since it requires a joint understanding how to use data in open networks and how to create the necessary trustful environment. If you allow me a personal remark, the trustful environment we're quite experienced when I look at roughly 70 meetings on working group level between our experts in RRI and Industrie 4.0. Key role will be the digitalization of global value chains as one of the key enablers for a more competitive, resilient, and climate-neutral economy. One challenge is to establish digital sovereignty. This means giving to companies and leaving with companies the control over the use and sharing of their data. In short, they remain in the driver's seat throughout the entire process. And as I said earlier on, industrial supply chains and value networks do not end at national borders. A global approach is undoubtedly required for the sake of business, for the sake of the development, and it's plain to see that digitalization and data is key and a base for every business in the time to come. And it serves companies as well as countries. And it saves money and it cuts costs. So the creation of global data-driven ecosystems is the next major development. It will transform industry across all sectors. There is a need for a truly global approach. So to make change happen, the International Manufacturing X initiative has been launched. It's threefold. First, to connect value chains and manufacturing data networks across industries and countries. Second, implement the global foundations for data-driven, resilient, sovereign, and climate-neutral production, what colleague has mentioned, and enable innovative value creation in an interoperable and sovereign data ecosystem. From my personal perspective, it is important that it is connectable and easy to use, especially for the small and medium-sized enterprises, which make, for Germany, 85% of our business. The lower the threshold to join and to make use of it, the better, because ultimately, there is no viable alternative to a data-based, internationally interlinked industry. The German industry will get involved in these developments, and we are, at the federal government, willing to make our contribution to the successful further development of international manufacturing X. Companies and government are only contributors to the success, to the common goal. We do our share and we invite others to do as well. Because from our perspective, government and companies, we only can together form the digital transformation. And together, we can ensure a competitive and a successful industry of tomorrow. In this spirit of trustful cooperation and learning from each other and enhancing our cooperation, I wish you a very good symposium and fruitful discussions. And thank you very much for your attention. Arigato.
Thank you very much, Mr. Hess. Now, we would like to move on to the sessions, the presentation. We are not planned for a Q&A time for this session. From the YouTube link, QA link, please use it for your questions, if any, with your name and your business. So we will have a presentation, a session on trustworthiness for value chains. From RRI, Industrial Cybersecurity AG, we have Mr. Furukawa from Toshiba, and also Dr. Klasen from Siemens, and also from Plattform Industrie 4.0 AG3. Over to you. Hello, everyone. I am from Toshiba. I'm Furukawa. I work for the Industrial Cybersecurity AG, and this is Mr. Klasen.
Germany and engaged in the industry, Platform Industrie for all.
So today we will talk about the industrial work group. We will talk about what we're discussing. So the contents are here. We will start with a quick introduction. And also, we will talk about the trustworthiness in supply chains and value chains, trustworthiness supporting infrastructure, and then Dr. Klasen will share topics of Germany and Europe, and then we will close with our future outlook. So this is a quick introduction of our group. Industry Security Action Group has Toshiba, Hitachi, Mitsubishi, Heavy Industrie, Emeritus, and Sony. So major Japanese manufacturing companies are all members. Our common goal is to address Industry 4.0 across borders. Information and goods will be traveling, and what are the security conditions needed for that. And also mutually for digital businesses to connect. There's a lot of information exchange. Data sharing was a key topic this morning. And how much, from a security perspective, can we promote trustworthiness is the key.
And what we do in the security working group of the Platform Industry for All, we develop recommendations for actions and concrete application examples for a secure networked industry. And in this case, security and trustworthiness is a central key factor for a global value chain with international standards and continuous awareness for security.
So manufacturing businesses in Japan and Germany come together to share knowledge and experience to work on security as a common area since 2016. The Hanover Messe held every year. We share our white papers to, for example, share our ideas about the trustworthiness chain. Now next, why we discuss about the trustworthiness, supply chain trustworthiness. I will share the background. So there are more supply chain attacks. Even the companies are prepared. There might be direct, indirect partners that could be influencing them for those attacks. And there are many stakeholders involved. In the morning, DX, digitalization were the topics. In manufacturing site, DX with AI and cloud are increasing the risks. And in EU, Cyber Resilience Act and other legal regulations, and even Japan, manufacturing economic laws about parts and products now are more required with applications for security. So for the main manufacturing makers to come together from both Japan and Germany is because efficiently, timely, we want to make sure how we can do post-productions and also how we can build trust with other stakeholders, and how smoothly we can build that relationship is the key and our motivation. Trustworthiness is something that I've been referring to here in this session. And in our group, the definition of trustworthiness, we refer to ISO. Ability to meet stakeholders' expectation in a demonstrable, verifiable, and measurable way. This is our definition. So the first area we tackled in supply chain, the trustworthiness, the organization's trustworthiness, and the supplier's, manufacturer's first transaction with the supplier, how trustworthiness can be secured. We thought about these areas. This diagram shows a general supply chain scenario. First, product services are provided from suppliers, and then to be delivered to the manufacturers or customers, there is retail distributors and manufacturers and distributors. We have trust domain and trust interaction points that we introduced as a new concept. Trust domain means trustworthiness in the definition we made. These are units that define the trustworthiness. Could be organization, it could be part of an organization. Supply chain is made by trust domains, and trust domains discuss and agree. Interaction points mean the interfaces of different trust domains. Trustworthiness concept, it follows the trust supply chain to build trust. Trustworthiness profile, TWP. So when the manufacturers choose their first, when they make their first choice of suppliers, they base it on trustworthiness. To meet their expectations, suppliers will show what they can do, so they will show their capabilities. The trustworthiness profile has the capability and also the expectations written there. This is how the supply chain trustworthiness between stakeholders can be established, and that's what we thought as a possibility. Next, I will hand it over to Mr. Klasen for the train of trustworthiness. こちらに関しては国際基準の状況がどうなっているかをまず確認しました。そして多くのセキュリティのアプローチがあることを理解しました。ごめんなさい。
Security approaches and also security standards which can be used for supply chains. But what is missing is there's not a harmonized or single standard suit set yet which provides assurance for multiple nodes, which supports automatic processing, what we of course need for Industry 4.0 and also for digitalization of this industry, which includes interoperability between different nodes, which enhances scalability, which is scalable from the application point of view, and which preserves confidentiality and privacy. Privacy also in the case of business privacy, because not every stakeholder wants to get all the information free for every other stakeholder. So this has to be controlled in a certain way. It has to be managed by the stakeholders, and we don't have these standards available yet.
Supply chain's trustworthiness is our topic here. And in the morning sessions, and as we heard in the earlier sessions, for circular society, there is the eco-design digital passport, product passport idea in Europe. In all the steps in the life cycle of the product of design, specification, and disposal, all the information will be digitalized. And the data can be shared among different stakeholders. Trustworthiness in supply chain has been a discussion point. Goods and services flow was what we paid attention to. But when we think of the overall value chain, value has been also an important topic, and also to secure data trustworthiness. What does it take? What does trustworthiness need? We realize that we have to discuss about that as well. Trustworthiness, when we think about it in the supply chain, the importance of the data is imminent. Trustworthiness in supply chain, different from that, we have new challenges that we're facing. Product users or consumers, not only limited to them, but we have to think of the trustworthiness end-to-end until the last stage. Scalability, clear governance will be also required. And the supply chain's indirect users could be using data. So that's another area of trustworthiness that we have to think of. Privacy, confidentiality are other considerations. And for multiple different supply chains and value chain connections should be considered for trustworthiness as well. And the data of goods and product-related information data, with more services based on that, the trustworthiness of the services and trustworthiness of data of these products are also important. With these challenges, trustworthiness is a value chain. What does it mean? We are having discussions with the members in Germany.
So next, looking at the supply chain trustworthiness and the supporting infrastructure that will be needed. This year, in spring, there was a white paper which was published which talked about a trustworthiness repository. A trustworthiness repository is between entities on the supply chain looking at trustworthiness expectation and sharing of capabilities. Expectations and capabilities incorporated into the trustworthiness profile refer to both sides of the entities on each side and is used as digital evidence. In the trustworthiness repository, there will be the linkage information that's tied to the trustworthiness profile. The trustworthiness profile can be open to anyone, and throughout the supply chain, it's connected together. So trustworthiness profile data includes information on both authenticity and integrity, which will be required. Through the supply chain, we do not wish unauthorized competitors to be able to reach this data, so the confidentiality of digital evidence is also needed. Additionally, with regard to digital evidence, to be able to have higher levels of trustability, we want to use trust anchors to be able to achieve this. Next, from Mr. Klasen, I'm going to ask him to talk about some additional information relating to supporting infrastructure.
Yeah, thank you. So such a supply chain trustworthiness needs a supporting infrastructure which can be composed or will be composed of several building blocks, which I want to explain here a little bit. What we need, of course, are secure identities of entities, and entities in this regard are stakeholders, but also are products and components. So we need secure identities for products and components, and we need secure identities for the stakeholders, which are part of this supply chain. We need a trustworthy infrastructure for realizing these identities, and such an infrastructure has to be global positioned, has to be worldwide, and has to be unbiased, it has to be non-discriminatory and robust. I will come to that later on. We need verifiable proofs for entities which proving the required properties, which entities, of course, can also be against stakeholders or also products. And the verifiable proof could be a certificate which has to be bound to the product, or it has to be bound to the stakeholder. And this binding along the supply chain has to be secured by appropriate mechanisms. So such that the evidence can be calculated at any time and at any stage in the supply chain processes. Also, we need mechanisms to exchange proofs along the supply chains, and we need for all of this suitable international standards as building blocks. International standards means ISO, IEC, JTC1, or typical SCOs, which are really global accessible for every national body, and build for standards on mutual agreement. So to make it clear, the mechanisms for such an infrastructure do exist from the technical point of view. That is not rocket science, it's not new. But to build these things together and provide an infrastructure, that is a big challenge which we have to meet. And this challenge has to be met also for other reasons, which I come back later on a little bit, when we talk shortly about the digital product passport. So the requirements for such an infrastructure, it has to be globally clippable and scalable. We have already said privacy, confidentiality preserving, we have said integrity, authenticity, and accountability. It has to be used, easy to use is very important. It has to be accessible for small, medium enterprises. Companies have to be able to use it, but also have to be able to leave it without any problem. After using it, it has to be robust, available, and resilient. So we have to be careful that not big players have the possibility to disturb the existence of such an infrastructure. There must not be a single point of failure, so it has to be decentralized or distributed, and not a centralized infrastructures as we have for other examples already implemented. It should be able to support distinct trustworthiness requirements, because not every product has the same requirement on trustworthiness. Not every business cases need fully cryptographically covered trustworthiness. Yeah, this has to be, we have to be able to apply it on demand, what we really need. And nevertheless, there has to be a clear governance, which is non-discriminatory, what I already said, and which is unbiased. And we do not have any construction in the world at the moment which is able to provide such a clear governance for global use. So going forward, I just want to give some examples where people in Germany and Europe are discussing such building blocks. There's one example where we have a couple of funded projects which are discussing the so-called sovereign identity approach, which is based on W3C standards, And usually from the definition is covering identities for individuals and organizations. But what we do at the moment also, we are checking whether this approach is also applicable for IoT components and IoT products. Here we, of course, have a scalability challenge, and we have also a very different challenge, which is also connected then with the solutions like DPP. If we have such a secure identity infrastructure used for products, for industrial products, this infrastructure has to support such a product for maybe 20, 30, 40 years. That's the lifetime of an industrial product. And this is very long, especially when we think about having cryptographic functions implemented in such an infrastructure, which usually have to be updated after 15 years or something like that. And of course, this comes not for free. Yeah, we have to think about mechanisms which really are able to support such a construction. Doesn't it? Also, I want to mention there's a new work item at TC65, which will, when it's finished, also support this lifecycle issue. This work item is defining events along such a value chain, specifying events, services, information models, and semantics for the interoperable information exchange between different stakeholders. And once we have such a standard, this is a very, very important building block where we also can build security and trustworthiness related information on that. Now, there's a regulation coming up in Europe, which was launched in 2022 from eco-design for sustainable product regulation. This regulation comes from people who want to control material flow for sustainability reasons and circular economy reasons. So for this digital product regulation, there is already a standardization committee founded recently on September 20 in Senelec, which is called Digital Product Passport. And this regulation is, this committee has a goal to define harmonized standards which can be used by companies which want to implement Digital Product Passport. And you see here on the line below information which is on the bottom, standardization work on DPP 4.0. Now, what is DPP 4.0? DPP 4.0 is based on the concept of a German Association for Electronic Industry. And the idea is to base such a digital product passport for Industry 4.0 components or for industrial components on existing and new IEC standards, which are called DNP 4.0, for the standards for digital nameplate and for the so-called asset administration shell, where I know that people also from your country are very engaged in the definition. Why I'm showing that on a talk about security? The point is, the idea behind is that this asset administration shell implementation of a DPP carries information for different purposes. One purpose is, of course, information which is free accessible by everybody who has access to the product and who has then access also to the information which has to be provided by regulation by everybody who wants to sell this product. But with similar mechanisms, the idea is that there is information linked with this product which is not free accessible. Some of the information may be accessible only for regulatory purposes, but some other information, that is block number 2 on digital services, may be made available for digital use cases for people who want to make money with data and want to make money with data which is produced with a product during the product's life cycle. That is the opportunity for digital services can be delivered together with the product and with the data from the product in the market by people who are manufacturing these devices. So, and of course, if you want to do that, then we again need this trustworthiness infrastructure, because what is behind that is some sort of e-commerce for data which is connected with a product. And when you want to deliver such data with a product during the full life cycle of a product, then you again need to support such a trustworthiness infrastructure for the full lifetime of a product. And that's a big challenge. And for standardization people in Europe, just now, I think they are realizing what the consequences of that is. This is something which does not come for free. That is something we need new ideas, and that is something that the community need to build this infrastructure, which has to be robust during the full lifetime. That's yours. Okay. Future outlook of our cooperation between Robot Revolution Initiative and Platform Industry for All in terms of security. So we want to further look into methodologies for trustworthiness for products and for derived information for products. In value networks, we will have a look at certain use cases. We will check and look how manufacturing X digital ecosystems related to our work, which we have done during the last years, and I think there's a lot of relation to that, because manufacturing X, at the end, we also need this sort of infrastructure in the back, and what we will do as a first step.
Yes, so up to this point, we've been in our presentation talking about the value network, the value of chain, trustworthiness chain. So data sharing is something that we've been talking about a lot, and thinking about security and the importance of trustworthiness. We've been putting that together in a white paper. So next year at the Hanover Messe, we're planning to present that. So we'll have some delicious white asparagus alongside our white paper in Germany. Thank you so much for listening to our presentation today.
Thank you very much.
Thank you very much, you too. At G7, DFFT is being discussed. That is the lowest bottom layer of data flow, free flow. And then today's discussion was more something closer to application. Next, from the expert panel, we have two speakers, Professor Kimura and Mr. Rudschuck, on digital twin usage and standardization. We have Professor Emeritus Kimura, and we also have DIN and VDE technology and electronic DKE Michael Rudschuck will take the podium. Thank you very much. I am willing to discuss the smart digital related discussions. I will give you the overview of the discussion, whereas Mr. Rudschuck will share with you the situation in Germany. Now, digital twin covers all artifacts to promote sustainability, and the importance is something that we would like to highlight in this presentation. And I would like to discuss material circulation and cost circulation. Here you can see the bullets. First, I would like to discuss the positioning of the expert panel before revisiting digital twin and usage of digital twin use cases, before concluding with the issues and challenges going forward. Digital twins are in use in many different ways, but this presentation focuses on the definition, under 3, Digital Twin Revisited. First, about the expert panel. Japan expert panel is about the standardization of smart manufacturing. It discusses important topics around this area to further promote collaboration. Specific issues include areas that demand international standardization. Issues thus exhibited and considered important, then ISO and IEC will be butted against to discuss further standardization. Now, in eliciting all these challenges, we have taken a top-down approach as shown on this slide. Smart manufacturing is still evolving. This means that we have to have a future vision so that standardization can be further promoted. Application scenario is a high-level description for further target. Before starting technical details, we come up with an application scenario to discuss the requirements needed for future standardization. This chart shows application scenario. With this business view, use cases are analyzed with usage view and functional view. By usage view, black box method is used to analyze the relations between the users and providers. We also discuss technical treatment needed. Before going into the details, usage view target of analysis needs to be understood in a deep manner to keep ourselves abreast with an overall view. Now, from usage to functional views, there are several interesting challenges that I would like to bring your attention to. First, meaningfulness of digital twins. For manufacturing or social activities, social sustainability needs to be improved. To this end, digital infrastructure supporting social affairs is indispensable. In this segment, digital twins can play a pivotal role. Smart manufacturing can benefit greatly from digital twins. Not only that, digital twin is an indispensable element needed for the world's transformation. Now, talking about global environmental issues, IPCC Intergovernmental Panel on Climate Change of UNFCCC has made it clear that anthropogenic activities is having a negative impact on this planet, and that is a scientifically proven concept. Manufacturing and other industrial activities impacts affairs of this planet, and that is why we need to improve the situation. There are several good news. IPCC report suggests that social change can, or transformation of our activities, can also reduce environmental burden on the planet. This also means that efficiency in manufacturing can be achieved, and this can be a strong motivation to promote smart manufacturing. Diverse and complex factors related to sustainability can be summarized as follows. For environmental sustainability, we need to reduce waste. To that end, product and other activities need to be visualized. Here, modeling can play a key role so that we can track the activities. And in this regard, digital twins can play a major role because that can play a pivotal role driving these goals. Let's discuss future society structures from a bird's eye point of view. Our society be it appliances, information technologies, automotives, or power or space systems, are all indispensable elements that supports our lives. Also, there are some intangible assets as well. These artifacts have been provided through manufacturing processes. When manufacturing becomes more digitalized, artifacts can also lead to a creation of a digital twins in the cyber world. Digital twins, product and technology agnostic interoperability can be ensured. If that can be ensured, digital twin-enabled social affairs can be synchronized, leading to creation of new values. For example, in agricultural machines and activities, distribution of food processing companies can be linked together. The same can be true in the medical and healthcare systems as well. This is a more concrete depiction of the roles digital twins can play for social affairs. Digital twins is designed to be useful in social activities as shown in this chart. Modeling functions of the digital twins can lead to the promotion of reuse or reconstruction. This modeling function needs to be established to have the digital twins to be linked in a cross-sectoral manner. Semantic interoperability is an assumption to promote data linkages. To this end, digital twins can play a major role. In this presentation, digital twin usage and functions are the topic of this presentation. Business usages and application will be discussed on a different occasion. Now, let's take a look at the definition of digital twins and basic functions before discussing standardization and its related elements. Recent years, digital twin has become a hot topic. There are some specific requirements, including standardization. There are different definitions of digital twins depending on the domains of activities. From a design perspective, this is one of the most widely used definitions. A digital twin is a digital representation of an active, unique product, real device, object, machine, service, or tangible assets, or unique product service system that has three major components. One is a physical entity in real space. Second is a virtual entity in virtual space. And most importantly, physical and virtual entities are communicating both ways with sufficient flow of data between the two. Over 40 years, physical entities has been modeled with product modeling technology. Modeling in and of itself has been an established technology. Especially over the last 10 years, modeling has been supported by developed information infrastructure. So the connection between physical and virtual entity has become closer and bi-directional. From the usage perspective, there are certain modeling interactions as shown on this slide.
Current applications of digital twin relate to self-production execution processes. So the models are built in response to manufacturing equipment in the physical world, and the information flow between them is more simple. But in real world, a model in the cyber world may be planned and designed, and an entity in the physical world constructed in response. or conversely, a model may be constructed in the cyber world by information from an entity in the physical world. The relationship of information flows of these models are complex, and the modeling capabilities for such needs have not been developed enough. This is an example, the cyber world and the physical world interaction. So a prototype. So versus the cyber world plan, in the physical world, there are many prototypes that will be created. And then for one product, there could be various application models in the cyber world. When you think of the entire life cycle, for each phase, there will be detail scales and there might be supply chain and assembly, and the model units would be different, for example. And with or without models, and the relationship between the cyber world and the physical world, there are many elements to be considered. So how can they be organized and harmonized is a big challenge. So we will talk about the ideal model to solve this challenge later. Based on the discussions that we have, we are thinking of standardizing the requirements. So still, the essence is not sufficiently understood. So through the entire life cycle of artifacts, the digital twin is a dynamic bi-directional relationship between the two worlds. Implementation for application is developing rapidly, but there is still a lot of work to be done to ensure that all the complexity is addressed. So to reduce complexity, to achieve full life cycle operability, and to establish a dynamic bi-directional relationship between the cyber and physical world, we think that standardization of digital twin is very important. So we need to have more discussions between the experts of Japan and Germany. But this list shows standardization topics related to digital twin. And when we think of standardization in individual application areas, these are going to be the bases. Reference models, architectural frameworks are complex and involves a mixture of issues from many different areas, so it is essential to standardize these areas. And semantic interoperability across different activities, technology, and product area is important for effective application of the digital twin. I could give you a concrete example. Carbon footprint integration in the global supply chain in order to calculate the CO2 emissions according to specific conditions as a context. We need the supply chain description as data for digital twin, and that has to be established as a common context description. So we need to establish a common basic concept, so-called ontology, to meet this need. A generic ontology is a difficult task, but for each area, for the basic areas, we can take approaches to standardize and then integrate them. And although not this is a specific standard, this is a reference model for digital twin that has been proposed. So we have 8 coordinate axis dimensions and their aspects. Such model is a standardized common IEC 63339 reference model, URMSM for smart manufacturing. So this is an existing standard, and we have compatibility with it. So as a reference model standardization, the relationship with this should be discussed. So the reference model's coordinated axes still have certain rules and restrictions. So we have to use them depending on the purpose. So this list might be ad hoc, includes some ad hoc matters, but there are some examples. So we need to continue to organize these and to create a library of coordinate accesses and aspects. This is going to be an important challenge for the future. As an example, we have RAMI 4.0, or Reference Architecture Model Industry 4.0. So it is an attempt to classify the various use cases of digital twin and analyze the interrelationship by setting up coordinate axes. So in red are the use cases that are not fully established yet, so we need to put more consideration in them. And we are still going through trials and errors, but we are hoping this approach will help to identify the gaps between the current state of development and the necessary use cases for effective development. So this is our approach for the semantic interoperability. For individual applications, we have definitions. Across different industries, we need to think about the difficulty of interoperability of the different standards. So we do need a cross-sectional setting. And this is not going to be realized in a short period, but this is an unavoidable task that we have to be continually addressing.
一例として共通の当時の一例として生産システムの環境影響評価
This also shows you the needed data. And this is one of such examples. About EIA data, environmental performance evaluation data, which has not really come online. But data ontology is now being constructed as a dictionary so that it can be referred to evaluate the EIA within digital twins. And interoperable construction of such EIA is indispensable. I'm running out of time, so I will pick up my speed. Carbon footprint calculation. At the motor construction, CO2 emission was calculated. Standby data can be extracted if you want to do so, but you have to contextualize when you are going to do that. The same can be said about the supply chain data extraction as well, when you're tallying up all those footprints. Either case, appropriate ontology needs to be the basis of digital twin-based calculation. That said, in order to achieve this, semantic interoperability is something that needs to be established. That also means that the relations between data needs to be established, so that semantic data model needs to be created. This is EPE, Environmental Performance Data Information Model, and this is one example of such description. Engineering data can also be defined, and lots of R&D has been promoted, but it needs never easy to make it as a general purpose model. And in order to drive all these views, functional and usage views should be the basis to collect use cases. Digital product passport example is being treated on this slide, and that is something that my colleague will discuss. And I will give the microphone.
Kimura-san. So let's come to a small intermezzo, and I will explain you why we as standardization organizations are so focused on the digital passport. We heard today a lot of lectures, presentations about the digital product passport, digital twin, and you have seen that they are more based on a, let me say, academic focus. But today, the digital product passport is not an academic gimmick anymore. The EU Commission released the proposal for the eco-design regulation for sustainable products on March 13th last year, and the digital product passport will be an essential part of this regulation. The digital product passport is here to revolutionize the way we will govern our physical products. It's like having a digital identity card for your products, complete with its own passport, photo, a unique digital fingerprint. But if you take a look at the proposed EU regulation, it's not cutting-edge technology. We are talking about technology from outer space. The technology has still arrived. Always keep in mind that the first pass will be a blueprint for all others. So we will start in Europe with battery, textiles, and all kinds of electronics. But the concept is so generic that in future we will extend it to all other products. So you will agree that in terms of standardization, we can't afford any mistakes here. And you will see on this slide the time scale. So today we are talking about 2023. We are in the middle of this timeline, but you see at the end, 2027, the EU Commission will issue first product passports. So at least we have 4 years for standardization, which is a very, let me say, ambitious game. So coming back to standardization, at the moment there's no decision made how the regarding finance technology will be. But the asset administration shell, so what we call DPP 4.0, is at the moment leading the race. Without going into details here, I will only refer to the German standardization roadmap Industrie 4.0. The link is below on that slide, so you can download this standardization roadmap and see what's behind our concept, what's behind of our concept we propose for the European digital product passport. So the digital product passport is no rocket science. You will see that all used technologies are really known and based on established concept. So here in our concept, we are starting with a QR code or barcode or whatever RFID chip. And with a suitable reader, we can come to a web service with an underlying database. So there's nothing new about this concept. It's only the way the data are it's only new that the data are completely interchangeable between all stakeholders and all during the life cycle. And that's the point where we as standardization organizations join the game. The picture shows a candy box with a digital nameplate, which had been already presented 2019. So since 2019, we were working on this concept. And for this standardized barcode, QR code, we have meanwhile an international standard, which is the IEC 61406, where also Japan was in lead. So, meanwhile, we extended our concepts at a demonstrator in cooperation with the ZVEE. And here we integrated digital standards, digital certificates, and also we had a program where you can calculate the carbon footprint which was produced for this particular item. So if you have an iPhone or on mobile phone, you can scan the QR codes and then you will be led to our internet sites on the right, links to the demonstrator. And also the QR code on this dummy product is still valid. So now back to Kimura-san. Thank you.
Thank you. So maybe I missed the time. 3 or 4 minutes?
3 minutes left.
Sorry. Okay. So also there are several,
So we are considering some use cases, for example, for reusing things. For reuse, we have to think of non-conventional data that we didn't use before, and we have to respond to the new digital twin requirements. So this is a list of the needs of the data, and some of the information had not been explicitly considered, which needs more consideration in the future. This is a use case of reusing electric vehicle battery, but in the interest of time, I'm going to skip the details. And in Japan, in the Japanese industry, it's often said that a new concept to try to have switching a huge heat treatment system into a compact one. So it is difficult to try to reduce trial and errors if we use the conventional approach. So we have to efficiently do production for the to-be situation. And with if we have like cyber world should be preceding a method which physical entities are constructed, and that is going to be a critical technology. So finally, I would like to think of the consideration points for digital twin. There are a lot of research development and application already in progress. ISO, IEC, JTC1 has informed the templates, and there's a lot that have been already accumulated. Standardization work, not limited to manufacturing, in a wide range of scopes is progressing. Activities are moving forward extensively, so working on reference model is also very active. So we need thorough review of these activities to accurately understand the current situation and the future trends. And then we are still discussing with experts from Japan and Germany, but we have these potential focus scopes. Number one, the scope of smart manufacturing. We will examine the reference architecture of digital twin with a view to widely apply it in the society. And as for the basis, secondly, we will need to develop further use cases and analyze them. For semantic interoperability improvement, we need semantic model with deep consideration. This closes my presentation. Thank you very much for your kind attention.
Thank you very much. On the subject of digital twins, physical being modeled in virtual environment, there are a variety of different methods for doing that. We don't want to get too scattergun approach on that. So thank you for presenting all that information. We'd like to move on to talk about a presentation regarding business ecosystems. This is from Mr. Kiyoshi Mizukami, RRI WGI advisor. Thank you very much, Mr. Mizukami. I'm an RRI advisor. My name is Mizukami. Thank you for giving me this opportunity today. So, first slide, please. Today I'm going to be talking about RRI's activities in terms of the special interest group number 9. This is the content that we're covering that I wanted to present to you all. I'd like to begin back in 2015 at this international symposium. I was talking about the importance of producing new value. In 2018, from Kagaman, Professor Kagaman, we heard about the B2B platform economy. And he posed the question, is that something that could be discussed? Subsequently, Platform Industry 4.0 with Mr. Wolfgang and others, we've been talking about what kind of systems could we have. On the other hand, in Germany, industrial value creation is something that is being viewed very critically and talked about a lot. Today, from Dr. Otto, he covered some of this in his presentation. One of the purposes was joint innovation, I believe, as the patterns that he described. Innovation itself is, of course, very broad. I'm not going to give it a definition for this forum, but thinking about innovation in the digital era, what does that mean? From a Japan Research Innovation Academics group, we've started with their help to looking at this. This is what I propose to cover today on this slide. Next, I begin with the activity purpose. Our hypothesis is innovation will change in the digital era. Innovation will be going into a different dimension to what we've had up to now. That was our hypothesis. If that is the case, then how will innovation change? What will it become? How will it be different from before? Today, I'm going to try and cover some of those topics. This is the membership of the people who have been involved in this discussion and debate. We've had multiple conversations, and I'm going to be sharing the outcomes today. Beginning with the approach. Let's base ourselves on a use case. Looking at industrial data exchange and other data sharing. Through that, what kind of thing could be doable? Let's take up a specific example from what we're familiar with now and imagine where that would take us. Based on that, we can look at innovation in the digital era and attempt to define what that means. Let me go into the content. Starting from imagining from a use case. The use case we've selected is something you'll all be very familiar with, Uber Eats. During the COVID pandemic, Uber Eats became very much used by many people. So let's think about industrial data sharing and data space. If we were to evolve this, what would happen? You'll all be familiar. Uber Eats is a delivery-focused service. It connects restaurants and users, creating a new relationship that didn't exist before. In other words, it's new value, a new concept which was born from this. Of course, if we think about it in the terms of digital, you use your smartphone. As a new interface, you might use electronic payment methods. So there are some new mechanisms that have come into play. On the other hand, new challenges were born from this too. For example, taste. The person who's delivering. Do you trust that delivery person? And if you think about gig economy, gig workers, what is their labor environment? This was raised as a concern. Solving these and evolving forward is something that's been happening. So the team, we talked about this. We discussed this and said, these might be areas where there could be connections with a variety of different sectors. Via a data space, maybe you could get involved with regional agriculture so that what's grown in the region is consumed in the region. Or thinking about health consciousness, coming up with healthy recipes as a service. Or thinking about experiencing something beyond your normal daily lives. You want to experience something special. That's one of the reasons why we go to a restaurant. It's a special place. So a rental space industry. And we were thinking about those with low incomes providing food. In Japan, we have these volunteer food facilities that serve inexpensive or free food to children. So maybe that could be something that could come from this. These were the kind of things we imagined. In order to do this, what should be done? What needs to be done? So, for example, thinking about a restaurant makes food, then you eat the food. Thinking about that process, it sounds very obvious. You generate a menu, you procure ingredients, you cook the food, you eat the food. As part of that, though, again, it seems very obvious in terms of information being handled. If that information is being handled in a standardized way, then you could very easily connect with all those other services that we imagined around what was happening now. That was our first outcome of our discussion. So through this, a variety of different stakeholders and a variety of different services could be connected here is our hypothesis. So let's think about innovation in the digital era. What does that mean? What did we gain from the use case? One of the things we identified is the labor process and the information that's handled in there, the business process and its information. If it's standardized, then it looks like it would be pretty easy to connect across sectors into other domains. Also, from the use cases, the use case that we looked at, materials, design, use by customers, all the way through to disposal. You could connect people with experiences and things. So we thought that there could be linking of different domains. In the real society out there, there are many existing concepts and preconceptions, like Uber Eats. In Japan, there's a word, demae. It means that somebody from a food facility, when they have a bit of time on their hands, they step out and deliver some food. So that was a preconception, and we've been able to shift into a new concept, which has created this Uber Eats mechanism. So extracting the new concept, forming the new concept, and connecting that with other sectors and domains. If we can identify all those things, then it's possible to embody and create new values and concepts. With digital, we're able to do that so much more easily. And that was one of the conclusions that our discussion reached. In other words, that this is the characteristic of innovation in the digital era. Having said that, if we're going to push ahead with this, there are still a variety of things that we need to study and consider. We need to form a new concept. We need to make it take shape. What do we do to do that? We still haven't figured all the details out. We've identified a few examples here. And furthermore, ultimately, this needs to lead to active economic efforts and activities, and support will need to be provided, whether in Germany, Europe, or in Japan. Talking about a system of systems, talking about shifting to ecosystems. These are per company, per individual, per country, not really realizable, and having scalability to develop those further, there has to be a wide variety of collaborative effort, as part of which, what should be industrial data exchange or industrial data sharing? Naturally, standardization need to be included in there, business models need to be included in there to identify how we can create a cooperative area and domain. In Japan, that discussion is still very challenged, and working with people outside of Japan, we hope that we can move that discussion forward. That's everything that I wanted to suggest as of today's forum from myself, and I hope that this will lead to the next step in activities. Thank you very much. That's it. Thank you for listening to my presentation.
Thank you very much. This is still a topic still at a very young phase. So this is also the area that we have to work on going forward. Now, collaboration in manufacturing data spaces. German-Japan collaboration, manufacturing data spaces. Professor Shinsuke Kondo remotely will join the discussion. He's the chairman of Manufacturing Data Space AG, and to be followed by Mr. Henning Bantien. Thank you very much for your kind introduction. I am Kondo of U Tokyo. So collaboration on manufacturing data spaces will be covered by myself and Mr. Bantien, Platform Industrie 4.0. Next slide, please. These are the points that I would like to cover, why we are doing this, and what we are doing in Germany and in Japan, and the thought processes that we have. Before conclusion, we would like to discuss how to promote collaboration between the two, and our initiatives to further promote collaboration will be covered. Next slide, please. First and foremost, let's take a look at the background. As you're aware, manufacturing industry's environment is changing dramatically, being social changes or economic changes with the rise of the block economy. And politically, there are a number of changes going on. Through these changes, regulations have been created, and AI and other technologies have also entered the society, further driving the changes in the society. And these are the realities manufacturing industries are facing. Individual companies or single country cannot deal with such mega trends or changes. We need to maintain the manufacturing capability at the same time dealing with all these changes. That can only be done by working together in areas possible with all the other stakeholders. Collaboration and cooperation requires cross-sectoral data space and creation of the data spaces for better utilization. Now, data sharing or data space creation, when we are trying to do that, what can be the challenges and hurdles? First and foremost, data space and data collaboration is something that is easier said than done. But they have different levels of granularity when you are talking about these things. Be it database or data collaboration, what are their definitions? Including interoperability, or data testing or resilience, or data sovereignty. What do these all mean for all the players in the landscape? That needs to be more deeply understood. Against this backdrop, we have been working together between Germany and Japan. And activities we are promoting needs to be mutually understood better, so that we can also explore opportunities for further cooperation. Next slide, please. Now, this is a message from Professor Kagarman. Please roll the video.
Distinguished guests, ladies and gentlemen, about 10 years ago, the final report of the Working Group Industry 4.0 was presented at the Hanover Fair to the German Chancellor and the international community. The strategic project started already in 2010 under the impression of the severe economic and financial crisis. Our goal was to strengthen the economic competitiveness by lifting the industry to a new level of adaptability and sustainability. Resilience was also a hot topic. The resilient factory, the first use case described in this report. In particular, the plug and produce capability was mentioned. That means that you are able to seamlessly replace an equipment by equipment from another vendor or to extend the setup of the production floor according to new demand. Another important topic was business model innovation. Future business models are based on smart services, and smart services are delivered on demand. They are tailor-made to customers' needs and a kind of a product service bundle that cannot be provided by a single company, but more from dynamic digital ecosystems across industries. To build resilient value chains, it's mandatory that you now can also easily substitute a business partner in an ecosystem by another one or extend the ecosystem by a new one. So the requirement of semantic interoperability that was raised by a resilient factory is now extended to all three dimensions, the technological, the business, and legal aspects, which makes international cooperation even more important. To understand the motivation and the approaches from other countries, Akatech conducted in 2017 a study, Industry 4.0 in the global context, commissioned by the Ministry of Economics. Of course, we found differences, but also common objectives that were on top of the priority list of all countries. Semantic interoperability by means of international standards, data security and data sovereignty, and the enablement of small and medium-sized enterprises. Small and medium-sized enterprise enablement can be achieved by giving these companies easy access to test beds and international cooperation. And that's what the Labs Network Industry 4.0 has achieved in the past, which I believe is a great success for proving international cooperation in practice. However, in particular, the small and medium-sized enterprises were reluctant to share data, in particular, sharing data via central digital platforms. But as we know, sharing data is necessary if you want to manage the cooperation within digital ecosystems as well as a collaboration between ecosystems. So the appropriate solution are open and federated data spaces with some architectural guidelines that support the trusted data exchange and guarantee data security and sovereignty as requested from all the interviews. At the same time, we finished a comprehensive study on the impact of autonomous systems in all phases of a citizen's daily life, at home, on the road, and at work. And the study confirmed the conviction of most experts that autonomous systems are mandatory to achieve the degree of adaptability and flexibility needed to implement Industry 4.0. With that, we have two additional challenges. One is the interaction between machines and humans. The gap is closing, so the interaction is becoming more similar to interacting with people in digital society. So together with experts from Japan, we investigated the future of human-machine collaboration and agreed how important it is to understand the historical and cultural background of the respective countries in order to find common solutions. The second challenge is machine-to-machine cooperation, in particular in distributed global setups, and to provide the guaranteed latency and bandwidth which is needed. And the answer is not the, let's say, original two-tier architecture that was shown 2012 and 13, like smart machines on-premise and public clouds. It's more a multi-tier architecture, a kind of an edge cloud continuum, which ranges from smart machines, on-premise edges, telco edges, to the cloud provider. The Manufacturing X initiative takes all these findings into account. It aims to implement decentralized and collaborative data spaces for smart manufacturing industries. The ambition is to set up a global foundation for resilient, sovereign, and climate-neutral production. And no country can achieve this alone. International cooperation, building on the positive experiences and the achievements from the past, is crucial to success. So the establishment of an international Manufacturing X Council is a promising and future-oriented step, and I wish all of you great success for a powerful start to lift international cooperation to the next level.
All right, then thank you to Professor Kagermann. There we go. So taking up the line of thoughts from Professor Kagermann and the historical view he has taken, just the view on what is happening right now in Germany and in Europe. I built 3 blocks: mega trends, sort of what are overall developments, then regulations, which are driving developments for companies in Europe, and then the market demands. About the mega trends, we have already spoken quite a bit during the day today and in the recent panel. But you see climate change as a challenge, the digitization, shortage of skilled labor, or geopolitical developments as we can see them at the moment. The other part is regulations, which is highly relevant for the work of companies. And I guess it is similar here in Japan as it is in Europe, that government does plan on various levels regulations looking at the very field we are active in, namely the digitization. And I just give you a snapshot of what is happening currently, or is enacted or in process in Europe on a regulatory basis. Now, you don't need to read this, right? But you can see very easily how complex it is, and how also, the risk is out there that some parts of this regulation won't really be consistent. And challenge-wise, this plays out on different levels. It's on a company level. How do you, as a single company, actually act with all these regulations? But it's also on an international level. It's not only within Europe, but it's also for companies from abroad, Japanese companies, US companies. If they work in Europe, they have to follow these regulations. So again, as it was also mentioned in earlier talks, the challenge for companies will be to find a smart way of actually dealing with this multitude of regulations and find automated ways and smart ways of actually implementing or operationalizing these kinds of regulations. I'll come back to that in a minute. Regarding market demands, you see the aspect of speed naturally is something very important. So here in Europe, in Germany, we are looking very much at the cases we already have, like Catena X or the Asset Administration Shell, to enforce and speed up the implementation of digital solutions. Added value is always very important. For example, what has just been presented to you, the digital product passport, or solutions around PCF. And lastly, clearly enough, innovation is super important. So how do we drive an AI or a database economy or automated processes, software as a service solutions? And now again, what I think is interesting to see is how do these things need to be linked up? So if you look, for example, at the megatrend of climate, you link it with the deal package, regulatory package around the Green Deal in Europe. And then you can, as a company, look at very specific solutions like the digital product passport, which can enable and facilitate and make life much easier for companies to actually work in this regulatory environment and also respond to overall challenges we're having. And as a final slide on the activities in Europe, you see here a compilation of the various activities that are taking place right now. So you see players on a more regulatory level who frame conditions on this overall level. Then you have organizations who actually advocate, coordinate, formulate the operational level of data spaces, what is to be thought of as fundamental building blocks. Then on the governance level, there are players who specifically look at the governance issues we're having, and then players who actually help to, on a technological level, think through and operationalize the idea of data spaces. This is then at the bottom part. But you need the entire ecosystem to actually be successful in driving these solutions. And having said that, back to Professor Kondo.
Thank you, Hanji-san.
Now let me introduce what is happening in Japan. Next slide, please. This is what is happening in Japan. Society 5.0 is something that I would like to start with. Society 5.0, as you can see on this slide, is closely linked with social and economic challenges. It intends to balance at all these factors, including but not limited to manufacturing activities. And that is the initiative being led by the Japanese government. This covers not only manufacturing industry, so there are lots of different players on the part of RRI, Society 5.0 as led by the government. We want to serve as an enabler with the Manufacturing X. There are lots of different players as far as Society 5.0 is concerned, including Data EX. Working together with these stakeholders, we are currently exploring the definition of the data space in this country, at the same time promoting mutual understanding with our international partners. Next slide, please. Against this backdrop, Action Group 4 was launched this year. As an initial step, we are currently working with member companies to explore the situation based on use cases. There are lots of different terminologies, and such discussion can be interesting but shallow, with limited depth in discussion and understanding. So we are paying particular attention to use cases. For companies and businesses, Society 5.0, economic benefit and increase in corporate value, that can possibly be balanced out with social agenda, but sometimes they don't. But it is important to strike out the balance, and it can possibly be achieved if we can wisely use data space, and that can be one of the major motivation on the part of the companies. So what kind of incentivization is possible? That is one of the questions that we are currently discussing. And then what kind of concerns can companies have having joined the data spaces? And that is the use case-based discussion we have started this year. In terms of thematic discussion, the first question is the clarification of the motivations or the factors that can motivate players on the part of the corporate players and on the part of social affairs. Second theme, when trying to enter into the data space, there are factors concepts or factors that may invite some concerns. What kind of concerns can be possible for each use cases, and how are these concerns are being explained and described? And these are the questions we are posing to better understand the possible concerns companies or other stakeholders can have. So in terms of motivation and concerns, we are trying to understand these in a concrete manner. And we are also trying to extract technological challenges that needs to be overcome going forward. Data space-driven engineering and manufacturing are also being explored in the working group as well. And that is what discussions are being taking place in our working group. And I'll give back the microphone.
So what we have now prepared is looking forward to our next steps, and with we, I mean Nakashima-san, Kondo-san, and Savila-san, who you have heard before. We were putting our heads together, and having heard what has been said so far, what we want to do now is really to look towards interoperable manufacturing data spaces, develop concepts between the two countries, to come up with a definition of common interests we have, identify potential collaborative areas for innovation, for the further development of manufacturing industries, and also to discuss sort of what are core building blocks of data spaces, and then to disseminate that joint understanding in our communities in the respective countries. In order to do that, we want to write a joint paper and have this paper for our mutual understanding, but also as an input to the international collaboration. And this is just roughly the table of contents we're looking at for this joint paper. You see, sort of after introduction, etc., we want to focus on what are drivers of change, what actually motivates us to build data spaces, what are the current situations in the respective countries, but then really to describe what do we understand as data spaces, what are design elements, what are learnings in the two countries. So to pull together these learnings and really out of the activities you have in Japan and we have in Germany and Europe to do something joint and with that to inspire also developments like manufacturing X. And the final step, I think, is really for us to define what then can be specifically, very concretely be done, with whom, what could be the potential partners in the countries to join forces and actually do implement and work together on data spaces. And in that sense, also here is our sort of call for participation to you all. So if you're interested in this topic, please contact us. If you want, join our activity regarding the joint paper, but also in more general, if you're interested in collaborating on data spaces, then please feel free to contact us. And then arigato, thank you very much for the attention.
Thank you very much. So the subtitle of this symposium is data linkage, and we will join our forces to approach this. So this is the last topic. There is an announcement with the International Manufacturing X Council. So Mr. Han from Deutsche Plattform Industrie 4.0 Siemens, and also Nakashima-san from RRI. We have video messages from the States and also from Australia. Hotta-san, thank you very much. This is the last part of the session. We are actually a bit behind schedule, so we might go over 3 minutes or 4 minutes. Sorry in advance. Up to here, we have been talking about the collaboration between Japan and Germany, and now as the last part, we would like to make one step even forward. So we would like to talk about the international collaboration. And we have some information to share with you. As International Manufacturing X Council, we are going to do an announcement, some unveiling, and I want to share some information about that. So first, Mr. Han will talk about international manufacturing X's current status and also our next steps. And then, in addition, and people from other regions who have been in the discussion, Mr. John Dyke of SESME, and also from Australia, we have Ciro's, Ms. Bronwyn, who is the chief scientist. So they have information about their regions and also what they expect on our efforts. We have video messages from them, which I would like to share with you. And then at the end, for closing, we will share some comments. So that will be the flow. So Mr. Han, please.
Thanks, Nakashima-san. And you see it, we do it together. We're switching over the position as needed. Also a very good signal and sign for cooperation. And you have heard a lot during the complete day, during this great symposium about what is needed, what are the challenges, what are the opportunities. And now, Nakashima-san, we have to get it done together. And that's, let's say, what we want to show you, what we want to make. And really, it's for me a great pleasure to announce this together with you here at this location. And as you said before, we have also the video message from America, from Dyke, USA, from Germany or Europe, from Japan, Asia, and from Australia, really to show this international aspects. When we are starting this, and I have only some slides, and we will hopefully not to overrun so much in the timing, a little bit explain why we are doing this. The why part was a lot of covered before. How we are doing this, and who is doing this. Really, here somehow a little bit the background and also the spirit in what we want to do this. So now I'm coming back to this slide, and I will not dig into the details of this slide. Don't be afraid of. But I give you, a short message why we are doing this. Markus has said this before when you're speaking about the threefold approach or the threefold topics about connected value chain, international, data-driven, and enable also value creation. I will start with an example, and Professor Kimura-san mentioned also, you have seen this curve about the broader carbon footprint. You have heard in the morning during the panel discussion from Ingo and from Hagen about Carina X. I think you have explained this as a theoretical carbon footprint when you have along the supply chain. Now we are speaking how we come to a real broader carbon footprint, and to make it, let's say, very concrete, we have also to optimize this. It's not only about reporting, it's also to feed it back in doing this. And when and I'm very sure a lot of people knowing, the percentage of the CO2 emission, which is, let's say, production is behind, is a higher double-digit number. So doing something it's important. That's the reason why I've used this again, this use case, because when you're going down to a shop floor, you see maybe, don't ask me, 10-20% of the CO2 footprint, let's say the so-called scope 1 and scope 2. You see it about what energy you're using, where you get the energy from, what material, what the production process is consuming, and what is the emission out of this. But a major part is maybe 80% is in the upstream, where you get the material for the production, or in the downstream, when you're speaking about, let's say, where the produced product is used in this environment. So meaning, in a nutshell, when we are not speaking together about what is on the upstream part, what is in the downstream part, what are the different products we are using, what are the different steps we are using, when we are not using this and calculating this and optimizing this, then we cannot achieve this, what we want to do, achieve or must achieve or should achieve when we're speaking about, in this example, the sustainability example regarding product carbon footprint. And as you can imagine, and this is somehow the bottom line, nobody can do this alone, or I like to use Boris' words, he make it very short, we have to team up. I think that is bringing a little bit on the spot what we have to do. And that is, let's say, a little bit to describe why. You have heard a lot of things about this in more details during the day, what we have spoken about. Let's go a little bit to the how we are doing this. You know, the sustainability part I have just covered. You know all the other topics. Resilience, think about Hagen's word about chip shortage or, let's say, rare material needs, how you can handle in supply chain to make the supply chain more resilient. And for sure, at the end is somehow where we can really achieve some kind of competitiveness. So that's what we want to target. And how we are doing this is here, or why we are doing this is here. You see it here on the left side, this ring with the different verticals. On the upper part right, you see a little car, it's a catena, or an automotive vertical. Then you see the machine tool building industry. This is, don't ask me, robot system. You see the process industry. So you see energy. When you have this plug for the cable, as example, and. So meaning, these are all a little bit depending to each other. For sure, one solution does not fit everything, but to have it interoperable, to exchange the necessary data, to build up a decentralized data ecosystem, as written here in the headline, is somehow key, and what we have to achieve, to fulfill the targets, the impact which you are seeing here on the right side. When you're looking about the how, a little bit about how we could structure this, I know this is a little bit a top-level view on the framework, what is behind this manufacturing circle, which I mentioned before. Then you have here on the top, for sure, we have to create something, we have to create some impact, as the targets. We have here also, and I think Ingo mentioned this also before in his presentation, about new business opportunities. With data economy, we can optimize, make more efficient our existing processes, but also we can look for new opportunities. Meaning also to new business opportunities, like we have shown before in the service parts and the predictive maintenance, and when a part is needed, to know it in advance, of course, is also, let's say, a very good business opportunities. And by the way, when you plan this, also a very good example from sustainability use case. So only to give it. Then we have use cases. I think every now successful organization is very use case driven. You see here some examples. Of course, you can extend the list of use cases when you're going to other verticals and so on. And you see here on the button shared services, asset administration shell is mentioned, Eclipse Dataspace connector is mentioned in the beginning from Hagen and later also from Boris Otto. The digital product passport is mentioned. The QR code, which I have shown, where you can identify, let's say, the product or can access to the documentation of the product. You mentioned this, let's say, in the context of regulation. I can tell you from industry is also a significant business use case because you have not to ship, don't ask me, tons of documentation. You can access as it is, but also access, let's say, the digital twin, let's phrase this, also the instance or the type data when you make it in a technical word. And all about this, you have to build up some kind of framework, regulatory framework, and standards. So that's only to give you a top-level overview. When you're speaking about the landscape, a lot was mentioned before. And by the way, before, with a foundational framework, this gives us also a lot of topics where we can address and will address joint developments, I think, for use cases, for shared services, and so on. When you're looking at the landscape, looking at the left side, you see a lot of initiatives First line are somehow mentioned, two are present today. You see, this, we named it infrastructure initiative, meaning IDSA, name it Data X, name it Gaia X, looking what is needed. And on the button you see also the standard and regulation. Only as examples, I see Shinji, for example, where we are together at the OPC Foundation, at the board, by the way, also wonderful cooperation, where we can address the standardization topic. Also meaning we have somehow to bring this, what we want to achieve somehow, let's say, in a way to orchestrate this. We need it to cooperate, we need it to influence and use where some systems, some infrastructure is there, and to define and lobby where needed when you're speaking about standards, for example. That's what we want to do, and you see this green box. This is all about what we want to start now. The International Manufacturing X Council, Henning Kagermann mentioned this before, and also several times, also from the two representatives from government was also mentioned before, that we have to do this and will do this, must do this, or however, which word we are using. The spirit is open cooperation in a partnership to define what we are. We are just working here on or have produced the first version of a playbook, how we are doing this, to show this. And as said before, it's not only our exercise, pleasure to make it here, by the way, I have to say it again, but you see here also on the bottom line some other logos from other initiatives around the world, from Canada, from some countries of Europe, from Australia, the logo is still missing, but will come soon. And you can imagine, and I'm very sure when this is announced, I think a lot of partners are, let's say, in this area active. But take with you is a joint cooperation, an open cooperation. We want to achieve something. We want to make something together. We want to create impact. We want to orchestrate and influence where necessary when you're speaking about standards. And we will exchange, the lessons learned which we have. Here is only for you a little bit an overview. You get all the slides. There are also some additional slides in the back about how we are doing this, what are the precise content is. But not to overstress you, and we are the last part, but maybe the famous one, I hope, of this session, that we are targeting this. And for sure, next step would be announcement in Europe and US. It will be on the October 25th. In some days, we will. Today is the first announcement, and we have the second one, and then we will see what is coming. We will have, and Markus has mentioned this also, and we have discussed this, by the way, yesterday in our meeting. We have to describe what is the data ecosystem, also touchable for small and medium-sized enterprises. I think we have a lot to do, also besides the technical stuff, to bring it, let's say, communicable and understandable and usable, also for the, especially for the small and medium-sized enterprises. Yeah, we have to set up the collaboration, and sorry to say this, we have just to work together. So many thanks, and a short and hopefully not so boring overview what we want to do. Many thanks.
Thank you very much. So next we have a video from the US.
Distinguished guests, ladies and gentlemen, it's an honor to address you today from the United States of America. My name is John Dyke, and I'm the Chief Executive Officer of the Clean Energy Smart Manufacturing Innovation Institute, also referred to as the Smart Manufacturing Institute. I'd like to briefly share with you who we are and share with you the nature of the work we do here at SESME, and close with our continued commitment to partnering with Japan and the newly formed International Manufacturing X community to engage in a global initiative for resilient, sovereign, and climate-neutral production. SESME was funded in 2017 by the Department of Energy as a program at UCLA to dramatically reduce the cost and time to implement smart manufacturing here in the US. Our aim is to create a more competitive and productive manufacturing operations and supply chain And we do that by investing roughly $200 million in advancing our technology, our workforce development, and our ecosystem strategies to democratize smart manufacturing. What we mean by democratize is to reduce cost and complexity by engaging the manufacturers, the systems integrators and consultants, the machine builders, the technology providers, and academia to innovate around the major challenges that we believe will help us accomplish our objectives for the United States of America. We fundamentally feel a sense of urgency around accelerating the adoption of smart manufacturing here in the US. We understand that the last 3 decades of manufacturing systems investment has left us with significant technical debt, stovepipe architectures and data silos, and that our more innovative, more agile, smart manufacturing future will involve much more interoperable and open systems, sustainable and energy efficient outcomes, and secure, scalable, and resilient architectures. We believe that that's how we engage not just the large manufacturers, but the small and medium manufacturers as well, who today are really struggling to implement these capabilities and for whom we need to focus on the accessibility of these types of strategies. And so we believe that this focus on interoperability and openness is something that we can't do alone, that we need to be working as a global ecosystem to advocate for the standardization of the appropriate architectures and information strategies, on ecosystem engagement, and more recently, with the creation of International Manufacturing X, the manufacturing data space development activities. We've had a great track record for almost 5 years now, working with our friends in Germany at the Plattform Industrie 4.0, working on the recognition that manufacturing is global, that supply chains are global, and that manufacturing revenues are global. It's really important to recognize that our manufacturing communities need us to align and harmonize and drive standardization around these important interoperability initiatives. And so in working with our friends there in Germany and more recently in Japan, it's been a privilege to develop practical strategies and then demonstrate those outcomes the way we did in Germany at Hanover Fair this past April around a joint demonstrator demonstrating a real practical approach to product carbon footprint reporting and measurement. And that's the sort of activity that we believe we can continue to invest in to advocate for the kind of transformation and harmonization that we think will help our global manufacturing ecosystem. Along the way, we've forged some great relationships with these organizations, but also with the great leaders that are part of these organizations, like Henning Bantian, Thomas Hahn, Dominic Rormus, Matthias Belke, and others. These bilateral partnerships have been an enormous value to our manufacturing community here in the US. And this is why we're excited to be a small part of your official announcement today regarding International Manufacturing X. We too wanted to stand alongside you there in Japan, at least virtually, and express our support for you and for this important international initiative to improve further sustainability, resilience, and competitiveness in manufacturing. This is not anything that we can do alone, and the topics we know we need to work on collaboratively with you and the rest of this community include the exchange of project best practices and lessons learned, trust frameworks, regulatory requirements, and the international standardization necessary for scaling up. Let's work together to establish a data economy for manufacturing, and let's work together to ensure the success of the International Manufacturing X Council. In conclusion, I wanted again to express my appreciation for this opportunity to address you today. We are excited to engage with all of you there in Japan and the rest of this great community to advance these vital strategies.
はい、今のはアメリカ。
So we had the CEO of SISMI from America, Mr. John Dyke. Thank you very much. We have another one.
to speak with you all today in this very important event in Japan. I'm particularly grateful to the Manufacturing X team and my friends Thomas Hahn and Dominic Rormus, with whom I've been working with on the delivery of Industrie 4.0 initiatives since 2016. Industrie 4.0 created an enormous paradigm shift for the digitalisation of production technology, and Manufacturing X will be the next major wave of innovation as we transition to the data economy. My role is the Chief Scientist of CSIRO, and for those of you who don't know us, CSIRO is Australia's national science agency, and it's one of the world's largest multidisciplinary science and technology organisations. We provide all levels of state and federal government with scientific evidence and analysis to inform policy making. We work with thousands of businesses, both large and small, across every sector of the Australian economy and with every major Australian university. We employ 6,226 people in Australia and around the world at 53 sites in countries including the United States and France. We collaborate extensively across the Indo-Pacific, including with our Quad partners, India, Japan and the US, to lift resilience in the region and tackle shared challenges like climate crisis. CSIRO has had the pleasure of collaborating with Japanese organisations since the mid-1980s across a broad range of universities, research organisations and the private sector. And we have had many, many successes together. For example, we collaborated on the Ultra battery developed by CSIRO and built by Furukawa Battery Company. It's now powering hybrid electric vehicles in Japan. We worked together to commercialise Barley Max, a high-fibre whole grain with enhanced nutritional benefits, developed by CSIRO and commercialised by Teijin under the name Super Barley. There are now more than 30 related food products in the Japanese market, and Teijin is expanding Super Barley across Asia. We're working together today on several renewable energy and hydrogen projects, including the Hydrogen Energy Supply Chain Project and others. CSIRO has a long history of innovation in close partnership with Japan, and I look forward to helping that continue as in my role as Chief Scientist. I want to briefly touch on CSIRO's research strategy. 6 years ago, we transformed CSIRO around the big challenges and opportunities that we saw coming for Australia, challenges and opportunities that we share with the world. That included a shift to climate mitigation and adaptation, digital transformation, agile manufacturing, and a One Health approach to protecting Australia from biosecurity threats like pandemics. It saw us refocus our research and commercialisation efforts around the 6 great challenges that we face as a nation. These are our food security and quality, a secure Australia and region, our energy and resources, our health and well-being, the resilience of our environment, and the innovation in our industries. 2 years ago, we announced a program of missions to help Australia tackle these challenges, and we've now launched missions to end plastic waste, catalyse a new hydrogen industry, build resistance to drought, produce more food more sustainably, and transform our agricultural exports. More recently, we have launched missions to tackle antimicrobial resistance, protect our waterways and coastal environments, to boost resilience to infectious disease, accelerate an industry pathway to net zero, and to convert Australia's critical energy metals into higher value products and protect our biosecurity. We are co-leading these missions with broad coalitions of domestic and international partners across the university sector, government and industry, because the challenges we face are challenges we all share, and they simply cannot be solved by one organisation alone. We are looking for more partners to join both our launched missions and the missions that we have in development. So if any of these areas align with your own goals, don't hesitate to reach out. One of CSIRO's largest business units is Data 61, with more than 1,000 people focused on creating Australia's data-driven future. CSIRO's Data 61 is at the forefront of digital science and innovation, leading leading both in developing new research as well as working across disciplines and sectors to apply technologies and drive impact. Data 61's three major priorities are to drive the development and adoption of artificial intelligence in Australia, including through CSIRO's leadership of the new National Artificial Intelligence Centre and the Next Generation AI Graduates Program. To put digital science and technology at the heart of Australia's recovery and resilience to help solve our immediate challenges and to help us anticipate and prepare for future ones. And thirdly, to reinvent the way science is done, using digitalisation to revolutionise the future of scientific discovery, including technologies such as AI. Data 61 are at the core of all of our missions, supporting this research with a data-driven approach. We see opportunities to collaborate with Japan on decarbonising industry and on eliminating plastic waste through a circular economy, both areas of significant research and investment for CSIRO, including within our missions program. We recently launched our Plastic Innovations Hub in Indonesia and Vietnam as part of our Indo-Pacific Plastic Innovation Network, and we are looking to expand that work in the region. And just briefly on the hydrogen front, I'm also aware that our hydrogen industry mission hosted a delegation of Australian researchers to Japan last December. And they met with the Japanese research community to explore R&D opportunities to accelerate a hydrogen industry in Australia and Japan. If you'd like to know more about that, I can connect you with our hydrogen mission. We're really excited about working on all of these initiatives which have a data-driven approach at their core with the Manufacturing X team to bring together Australian industry partners to harness the power of the global data economy. And we're looking forward to working with our great friends in Japan. Thank you.
So before we wrap up, from Germany, any comment?
Very short. Nakashima-san, we have to do it.
Yep.
Looking forward for the topic. Just do it, we promised something, we're showing the network capabilities, we're showing also the challenges, so the not so small topic what we're addressing, and as I said before, we can, must, and should do it. Many thanks.
Thank you. ありがとうございます。
Thank you very much. Inside the country, outside the country, we have a lot of collaboration partners, and we will excel our partnership to be interoperable and useful, Manufacturing X world to be built. Thank you very much, everyone.
Thank you very much. At RRI, our Japan-German collaboration will be the basis for our international activities, and we hope to continue to work on that. Very briefly, I would like to give some closing remarks. Today, we have been joined by Mr. Hess, Mr. Han from Germany. Thank you so much for being here. And also, as shown on here, we have been blessed with many supporters in terms of sponsors this year, and I would like to offer my grateful thanks to all of our sponsors. At RRI, we have picked up two big areas of activity, robots and IoT. Today's symposium was more about the IoT. It's one of our big events for IoT. IoT is supported by this structure that's on the screen in front of you now. At the very top, we have our two chairmen, our joint chairmen, Mr. Dr. Irie from Hitachi and Mr. Murakami from Ayaji. They, of course, joined our panels earlier on in our earlier sessions. We have 4 action groups which are there. We have university professors who support that, so that there's collaboration between industry and academia. That's a key feature of our team. Here on this next slide, this shows us in the field of IoT, one of the key things is German-Japanese collaboration. As you can see here today, we've been talking about these 4 different themes. These are the things that we're engaged in right now, and we want to produce outcomes and results based on this. With this, we want to be able to come up with meaningful proposals to METI in Japan. With that, that is very much the end of our events so far in terms of our International Symposium for 2023. I thank you all for your participation. Thank you.